Welcome to the Saksham based process control training series. In this course, we will build a complete continuous juice pasteurization and blending system using the Saksham ecosystem and Codices automation platform. In today's module, we start with the very first stage of the process, the raw intake system. We need to bring raw juice from a storage tank into the process line, monitor the tank level and make sure the tank never overflows. To achieve this, we will use two powerful blocks of the Saksham library. DACA block for analog signal scaling, on-off valve block for automation valve control. Let's now move into the codices and start implementing the logic. First, we need to add the DACA block into our fast loop program. From the toolbox, drag a box into the program workspace, click on the box and then click three-dot menu that open a library browser. Now navigate to the Saksham Advanced Library. Inside the library, open basic folder. Here you will find the DACA block. Select DACA and click OK. Now the DACA block is inserted into the fast loop program and provide the tag name as given li101 and click enter. Now in this window click on the three dot of initialization. Here you will provide all the necessary initialization parameter like PV high limit as 6. Set the value of different alarm as 1, 2, 4 and 4.5. Also provide the tag name and description. This tag will represent the level indication for the tank 101.
Now click OK.
Once the block is inserted, all the DACA parameters become visible and we can start configuring the signal scaling. Next, we connect the real analog input signal coming from the level transmitter. From the toolbox, drag an input and connect it to the AIPV pin of the DACA block. Now click on the three-dot menu next to the input and navigate to Application HWConfig and Rack 1. Inside the Rack 1, select the AI16 analog input module, that is R1S1 AI01, and add the PV and define the required channel corresponding to the transmitter signal. Now click OK. At this point, the physical analog from the transmitter is connected to the DACA block. The DACA block will convert the 4 to 20 milliamp signal into a level value between 0 to 6 meters. Next, we add a SOV-SA valve block from the Saksham library. From the toolbox, drag another box into the fast loop program. In the box, type SOV-SA and click OK. This is another method to use the block from the library if you know the exact name of the block. Now assign the tag name of the block as XV101 and click OK. Now add the real status of the wall input box from the toolbox and click on three dot and select XV101 underscore ZSO of the rack 1 and click OK. Now connect this input to the IOZSO. Similarly, drag another input block and connect it to the IOZSC by selecting the XV101 underscore ZSC of rack 101. Next, we add a simply safety interlock condition. If the tank level becomes greater than PVHH alarm limit of the LI101, the inlet valve must close automatically. For this, drag an input block and enter the DACA tag name li101.pvhh underscore ALM and click OK. Now connect another input to the cycle time by dragging an input block and click on three dot. Now expand the advanced library by click on the plus icon and expand the GBL system tags and select the variable fast cycle time and click OK. Now click on the initialization column in the front of XV101 to enter the initialization value. This is another method to provide the initialization. Enter the tag name and description and click OK. Drag a output from the toolbox and connect with CMD. In this, enter the value XV101 CMD. This will send a signal to the wall to close or open the wall. Now, we generate the code and log in into the controller. As there is no error, double click on the S851 from the devices, click on the scan network, select the device, enter the username and password and click OK. Click login, confirm with a yes and click start. At this point, the program begins executing in real time. The DACA block is now scaling the sensor continuously and the wall logic is active. Now we connect the logic block to the SCADA visualization screen for the better understanding. Now open the SCADA project, click on the pasteurization visualization from the device. Here tank and pipes are already present. Now we are going to add the DACA and MOV which we already added in the logic. Click on the current project in the visualization toolbox. In the search box type BL_DACA and drag the BL_DACA_tag in the visualization and place it on the tank. Click OK. Now connect the reference in the properties. Expand the reference and BL_DACA_tag in the point dig enter 2 and in the front of tag DACA FP double click and then click on the three dot to connect it to the tag. Expand the structure as data source object, then data source application fast loop and select the LI101 that is DACA as we defined in the logic. Similarly, add a SOV/SA valve in the visualization by searching and dragging it in the visualization. Connect the reference with XV101. Now to show the level of tank visually, add a level valve from the visualization toolbox. Click on measurement control and drag a bar display to the visualization over tank. Adjust the size vertically. Now connect this bar display to the value. Double click on the column in front of the value. Click on three dot and connect it with the PV of the DACA LI101 and click OK. To set the scale, expand the scale from properties. Double click on 0 in front of the scale start and click on the icon right to the scale start. Below this, double click on the column and connect it with PV low of LI101. Similarly, set the scale end with the variable PVHI. Now click on the generate code. As there is no error, click on the device codices HMI in the device section. Click on the scan device. Double click on the selected device. Enter the username and password and click OK. Now click on the login icon. Click OK and start the device. Now you can see the visualization in front of you. Click on the login, enter the username ENGG and password ENGG12 and click OK. Now to activate the alarm of the DACA, click on the tag name of the DACA. A faceplate will open. Switch it to Advanced tab and select all the checkbox in the alarm setting left to the alarm. As here you can see alarm limit which you entered in the initialization of the DACA in the logic. Now set the unit of the DACA to M as tank level in meters. Now click on the XV101 valve. As here you can see the valve is ready and all permission are okay. Click on the open button from the faceplate of valve. As you can see valve opened and level of the tank begin to rise. Now wait as the level rise to the high limit. As soon as level goes beyond the HH alarm limit, the value goes in the interlock condition and valve stop the flow. In this module, how to use the DACA block for analog scaling, implement automatic overflow protection, control valve using on-off valve block, visualize the entire system on SCADA. In the next module, we will implement temperature control and pasteurization process using the PID block and control valve. See you in the next episode of Saksham based process control series.